Good morning, students, and welcome back. Hope you all are fine and safe. Today, we will study the next topic from Science 1, lesson number 8, Metallurgy. That is, ionic compounds and metallurgy and its occurrence. Ionic compounds. We have learned that ionic compounds are formed from two units, namely a cation and anions. We also know that there is an electrostatic force of attraction between oppositely charged ion, which is called an ionic bond. Since the number of cation and anion in the compound and the magnitude of electric charge balance each other, an ionic compound is electrically neutral. What is the structure of ionic compound? Ionic compound are usually crystalline solid. Crystalline solids have a definite shape and smooth, shiny surface. The regular arrangement of ions is responsible for crystalline nature of solid. This arrangement is different in different ionic compounds, and therefore the shape of the crystals are also different. The specific arrangement of ions in a crystal is mainly due to attractive force between oppositely charged ions and the repulsive force between similar charged ions. Thus, in a crystal, negative ions are arranged around the positive ion and positive ions are arranged around the negative ions. Since there is a strong electrostatic force of attraction between the oppositely charged ions, crystalline solid have high melting and boiling point, and they are also hard and brittle. Factors responsible for a certain crystal structure are: first one, size of positive and negative charge ions. Second, magnitude of electrical charge on the ions. Let us perform some activity to understand some properties of ionic compound. Take sample of sodium chloride, potassium iodide and barium chloride. Observe the samples. They are all crystalline solids. Now, let us take each sample one by one on a metal spatula and observe the changes taking place when they are heated on a burner. We shall begin with sodium chloride. Heat sodium chloride. What do you observe? Sodium chloride does not melt easily. On heating strongly, it melts and gets converted to the liquid state. Potassium iodide and barium chloride also melt after prolonged heating. Prepare an electrolytic cell by connecting the carbon electrodes to the positive and negative terminal of the battery. Connect the battery in the circuit. Insert the electrode first in the solution of sodium chloride. Switch on the current. What do you observe? The bulb glows. Similarly, let us check the same for other solutions. The bulb glows when each of the other salt solutions are used. This shows that all the salt solution can conduct electricity. Now, on the basis of these activities, let us summarize the properties of ionic compounds. General properties of ionic compounds. Ionic compounds exist in the solid states because the positive and negative charge ions are held together by a strong force of attraction. This also makes them hard. Ionic compounds are brittle and are broken down into pieces by applying pressure. Ionic compounds have high melting and boiling points compared to water, which is non-ionic compound. This is because a considerable amount of energy is required to make the strong force of attraction between the oppositely charged ions. Ionic compounds are soluble in water and insoluble in organic solvents like petrol, kerosene and benzene. Let us understand reason behind this. When an ionic compound dissolves in water, the compound dissociates into ions. The water molecule orient themselves around the ions in a peculiar manner. Thus, a new force of attraction is established between the ions and the water molecules, which replace the original intermolecular force of attraction. This results in the formation of aqueous solution. When an ionic compound is added to a solvent like kerosene, unlike water, a new attractive force is not established and hence the compound does not dissolve in kerosene. Solid ionic compounds do not conduct electricity because the ions in them are not free to conduct electricity. When these compounds are dissolved in water or when they are melted, the ions become free to move and can conduct electricity. The aqueous solution of ionic compounds conduct electricity as they contain the dissociated ions. When electricity is passed to the solution, the ions move towards the oppositely charged electrode and there is a flow of electricity. Due to this property of conducting electricity in fused and dissolved states, ionic compounds are called electrolytes. Let us proceed to the next topic, metallurgy. The science and technology regarding the extraction of metals from ores and their purification for the use is called metallurgy. Occurrence of metals. Metals occur in the nature in the free state and in the combined state. Reactive metals are found in the combined state as their salt such as oxides, carbonates, sulfides and nitrates. Unreactive metals like silver, gold, platinum that are not affected by air, water and other natural factors generally occur in the free state. The compounds of metals that occur in nature along with other impurities are called minerals. Minerals from which metals can be separated economically are called ores. Along with metal compound, ores also contain certain impurities like soil, sand and rocky substances, earthy particles, etc. These impurities are called gangue. Metals can be extracted from their ores by means of various methods of separation. After the ore is mixed, it has to be converted into pure metal. The process of obtaining a metal from its ore is called extraction. The process which involves the extraction of metals in the pure form from their ores are included in metallurgy. Minerals are just taken out from ore mines. When the gangue is separated from ore by various methods, the ores are then carried to the place where metals are produced. Here the metals are extracted in the pure form. The metals are further purified by using different methods of purification. All these processes are together called metallurgy. Basic principle of metallurgy. Let us understand the different stages of extraction of pure metal from the ore. First one, concentration of ores. The process of separating the gangue from the ore is called concentration of the ore. This process increases the concentration of the desired metal. The method used for concentration depends upon first one, physical properties of the metals present in the ore and of the gangue present in the ore. The method also depends upon the reactivity of the metal. Let us make familiar ourselves with some general method of concentration of ores. First one, separation based on gravitation. In this method, the heavy particles of ores are separated from light particles of gangue by the method based on gravitation. Let us understand some method based on this principle. First one, Wilfley table method. The Wilfley table is an inclined table made by fixing narrow and a thin wooden wedges or blocks. The table is continuously vibrating. The powder ore obtained from lump of ore using a bronze mill is poured on the table. Simultaneously, stream of water is also released from the upper side. As a result, lighter gangue particle carried away along with the flowing water, while the heavier particle which contain high proportion of minerals and less proportion of gangue particles that are blocked by the wooden wedges are collected between the slits. Second method is hydraulic separating method. This method work on the principle of working of mills. There is a tapering vessel similar to the one used in the grinding mills. This tapering vessel or tank has an inlet of water from lower side and outlet of gangue on the upper side. Finely ground ores is released into the tank. A fast stream of water is introduced in the tank from the lower side. The gangue particles, being lighter, flow along with the water from the outlet, while heavy particles are collected in the bottom in the lower side of the tank. While particles of the same size are separated as per their weight with the help of water, it can be said that this method is based on law of gravitation. Let us proceed to the next method of concentration of the ore, which is based on magnetic properties of substances, that is magnetic separation method. This separating technique requires a electromagnetic machine. The machine consists of two types of rollers and a conveyor belt which moves continuously around them. One of the roller is non-magnetic while the other is electromagnetic. The conveyor belt which is moving around the rollers made up of non-magnetic material, that is, it is made up of leather or brass. The powder ore is placed at the end of the conveyor belt, which is on one side of non-magnetic roller. There are two collective vessels placed below the magnetic rollers. The particles of the ore which are non-magnetic in nature are not attached towards the magnetic roller. They are carrying further along the belt and are collected in a collector vessel which is away from the magnetic roller. The particles of the magnetic ingredient of the ore sticks to the magnetic roller and falls in the collector vessel near the belt. This technique is used to separate components of a mixture which are magnetic in nature. By this technique, magnetic particles can be separated from the non-magnetic particles of the ore. Cassiterite is the tin ore. It contains the magnetic ingredient ferrous tungstate, that is FeWO4, and the non-magnetic ingredient stannic oxide, that is SnO2. This ore can be separated by the electromagnetic method. The next method is the froth flotation method. Froth flotation method is based on the hydrophilic, that is the water loving properties, and hydrophobic, that is water repelling properties of the particles. This method is generally used for sulfides ore. The metal sulfide particles get wetted mainly with oil due to their hydrophobic properties, while the gangue particle get wetted with the water due to hydrophilic properties. Let us understand this method in detail. First, the finely ground ore is put into the big tank containing the lot of water. Then a certain vegetable oil like pine oil or eucalyptus oil is put in water for the formation of froth. Pressurized air is then blown to the water. In the center of the tank, there is an agitator which is constantly rotating around the central axis. The blown air causes bubbles into the mixture. The agitation causes formation of foam due to the oil, water and air bubbles. This foam rises to the surface of the water and floats. This is the reason the method is called froth flotation method. Certain sulfide ore particles preferentially get wetted by oil and hence float with the foam on water. Sulfide ores like zinc blende, that is ZnS, and copper pyrite, that is CuFeS2, are connected by this method. In our day-to-day life too, we come across certain objects which shows preferential wetting. Have you observed the colocasia leaf? The colocasia leaves are waterproof. The leaves have a waxy coating due to which water does not remain on the leaves. You may have also observed that wax cannot be wetted by water, but salt and soap can be easily wetted with water. Let's proceed to the next method, leaching method. The leaching method is generally first step in the extraction process of metals like gold, silver and aluminium from their ores. In this method, ore is soaked in a certain solution for a long time. A chemical reaction takes place due to which the ores dissolve in the solution. The gangue does not react with the solution, hence it does not dissolve in it. In this way, it is separated from the ore's bauxite, which is the aluminium. Ore is concentrated by the method of leaching. In this process, bauxite is soaked in aqueous sodium hydroxide or aqueous sodium carbonate. The main ingredient of ore is alumina. Alumina dissolves in the solution while the gangue does not dissolve. Thus, the ore is concentrated. This process used for the extraction of metals depend upon their reactivity. Now let us first understand the extraction of reactive metals. Extraction of reactive metals. Metals placed on top of the reactive series are highly reactive. For example, potassium, sodium and aluminium. Reactive metals have a large capacity to form cations by losing electron present in their outermost shell. Reactive metals react vigorously with dilute acid to liberate hydrogen gas. Highly reactive metals burn by reacting with oxygen from the air even at room temperature. Reactive metals usually occur in the form of their oxide or chlorides. The process of electrolytic reduction is used to obtain the metal from the oxide or metal chloride. The metal sodium, calcium and magnesium are obtained by the electrolysis of their molten chlorides. In this process, the pure metal is obtained at cathode and chloride gas is obtained at anode. For example, in the electrolysis of molten sodium chloride, sodium metal is obtained at the cathode and chloride gas is at anode. In the electrolysis of molten magnesium chloride, magnesium metal is obtained at cathode and chloride gas is obtained at anode. In the electrolysis of molten calcium chloride, calcium metal is obtained at cathode and chlorine gas is obtained at anode. Similarly, aluminium is also obtained by the process of electrolysis reduction of its oxide. Let us first understand how the metal aluminium is extracted from its ore bauxite. Extraction of aluminium. Aluminium is a silvery white metal. Its symbol is Al and it belongs to group 13 of the periodic table. Its atomic number is 13 with electronic configuration 283. Aluminium shows a fixed valency of 3 in its compound. Aluminium is a reactive metal. It occurs as an oxide in nature. Aluminium is the third highly abundant element in the earth crust after oxygen and silicon. The most important and common ore of aluminium is bauxite, which is hydrated aluminium oxide, that is Al2O3NH2O. The ore contains about 30 to 70% of aluminium oxide. The remaining portion is gangue, which is made up of sand, that is silicon dioxide, and iron dioxide. The extraction of aluminium involves two steps. First step is the concentration of the ore and the second step is the electrolytic reduction of pure aluminium. Step 1. Concentration of the ore. Bauxite is the main ore of aluminium. It contains the impurity silicon dioxide, that is SiO2, ferric oxide, that is Fe2O3, and titanium oxide, that is TiO2. The concentration of the ore involves the separation of these impurities by leaching and conversion of the bauxite into pure aluminium oxide or alumina. This process used here is called Bayer's process or Hall's process. In the Bayer's method, the bauxite ore is first crushed in the ball mills and is leached by treating concentrated sodium hydroxide or caustic soda under pressure for about 2 to 8 hours and a temperature of about 140 to 150 degrees Celsius. This process is carried out in a tank called a digester. Aluminium oxide of the bauxite ore is amphoteric in nature, that is, it can react with an acid as well as base to form salt and water. It reacts with aqueous NaOH, sodium hydroxide, and dissolve in it form water soluble sodium aluminate. This process is called leaching of bauxite by sodium hydroxide. Sand or silica present in the gangue also dissolve in the aqueous sodium hydroxide to form water soluble sodium silicate. Iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. It is then separated by filtration. The filtrate now contain aqueous sodium aluminate and water soluble sodium silicate. The filtrate is now diluted with water and then cooled to 50 degrees Celsius. At this stage, sodium aluminate gets hydrolyzed to form aluminium hydroxide. In the Hall's process, the ore is powdered and leached by heating by aqueous solution of sodium carbonate to form water-soluble sodium aluminate. This process takes place in the digester. The impurities present in the ore do not dissolve in sodium carbonate. They are separated by filtration. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of the aluminium hydroxide. Aluminium hydroxide is obtained by both. The process is filtered, washed, dried and ignited about 100 degrees Celsius to obtain pure aluminium oxide, which is also called as alumina. This method is called calcination. The next step is the electrolytic reduction of alumina. Step 2. Electrolytic reduction of alumina. Electrolytic reduction or electrolysis is carried out by a large steel tank which has the graphite lining in the inner side. This lining acts as cathode. There is a set of carbon rod or graphite rod dipped in the molten electrolyte, that is alumina, which act as anode. Pure alumina has a high melting point which is greater than 2000 degrees Celsius. In order to lower the melting point, pure alumina is mixed with molten cryolite, that is Na3Al6, and fluorspar, that is CaF2, and then melted in a steel tank. Thus, electrolysis can be carried out at about 1000 degrees Celsius. Now, let us see the reaction taking place during the electrolysis of alumina on passing an electrolytic current. Electrolysis of alumina takes place during electrolysis. The negatively charged oxide ions are attached to the anode. Here, lose electrons to form oxygen gas and the positively alumina ions are attached to the cathode. Here they gains electron to form molten aluminium metal. Molten aluminium is dense than the electrolytic. Hence, it is collected at the bottom of the tank. It has to be removed from time to time. Oxygen gas liberated at anode has tendency to react with carbon and oxygen to form carbon dioxide gas. So, the carbon anodes are gradually oxidized or consumed during electrolysis, and therefore they have to be replaced from time to time. Now, let us discuss the extraction of moderately reactive metals. Extraction of moderately reactive metals. Metals placed in middle of the reactivity series, that is zinc, iron, tin, lead, are moderately reactive. These metals are usually present in the form of their sulfides or carbonates. It is easier to obtain a metal from its metal oxide by reduction than from its metal sulfide or metal carbonates. Metal sulfide or metal carbonates are first converted to metal oxide by process like roasting or calcination. Roasting and calcination. In the method of roasting, the sulfide ore is heated strongly in the presence of excess of air to convert it into metal oxide. For example, zinc occurs in the form of zinc sulfide in its ore. Zinc blend. Zinc sulfide, when heated strongly in presence of air, can be converted into zinc oxide. Carbonate ore can be converted into metal oxide by process known as calcination. In this method, the carbonate ore is heated strongly in the presence of limited supply of air, and zinc also occurs as zinc carbonate in its ore. Calamite. Zinc carbonate, when heated strongly in presence of limited supply of air gets converted to zinc oxide. The metal oxide, so obtained by calcination or roasting, is reduced to zinc by reducing agent like carbon. Beside carbon, highly reactive metals like sodium, calcium, aluminium are used as reducing agent. To obtain the metal from the metal oxide, these metals can be used and displaced the moderately reactive metal from its compound. For example, manganese metal is obtained from its oxide when it is ignited with aluminium powder. Here, aluminium acts as a reducing agent. In this reaction, aluminium is oxidized to aluminium oxide and manganese dioxide is reduced to manganese. It is a exothermic reaction and the metal manganese produced is in the molten stage. This is also a displacement reaction in which manganese is displaced by aluminium. Another such type of reaction using aluminium as a reducing agent is the thermite reaction. Here iron oxide is reduced by aluminium powder to produce the metal iron in the molten state. This property of reduction of aluminium is used in thermite welding for joining broken piece of railway tracks. The molten iron formed from the reaction between iron oxide and aluminium is poured between the broken rails to weld or to join them. Now let us discuss the extraction method used for less reactive metals. Metals placed at the bottom of the reactivity series are the least reactive. For example, copper, silver, gold. These metals can be extracted from the oxide or sulfide are by just heating in air. Copper is found as copper sulfide in its ore, copper glans. When the copper sulfide ore is heated in air, part of the copper sulfide is oxidized with copper oxide. Sulfur dioxide is also formed in the reaction when the supply of air is stopped. The copper dioxide formed earlier reacts with copper sulfide to form copper metal and sulfur dioxide. Similarly, mercury is obtained from its cinnabar. When the ore is heated in the air, mercury sulfide is first converted into mercury oxide and sulfur dioxide. When this mercury oxide is further heated, it gets reduces to mercury. Metals obtained after reduction process may contain impurities. This process of purifying impure metal is called refining. Refining of metals. The most widely used method of refining metal is electrolytic refining. In this process, the impure metal is connected at the positive terminal of the batteries and a thin slit of pure metal is connected at the negative terminal. The water soluble salt of the metal to be refined is taken as the electrolyte. On passing an electric current, the impure metal dissolves from the anode and goes into the electrolyte. The metal from the electrolyte deposited on the cathode. The soluble impurities present in the impure metal goes in the solution, whereas the insoluble impurities settle down at the bottom of the anode. In this way, the pure metal is produced at the cathode. What is meant by corrosion of metals? You must have observed the iron object, if remained unused for some time, gets rusted. This process is called corrosion. Let us know more about corrosions of metal in next lecture. So students, today we have studied ionic compounds, metallurgy and various concepts of metallurgy. Hope you all have understood the topic. Thank you. Stay home, stay safe.